here we go. We're going to tackle this. And it's a three-step process.
Yep.
We're going to start with this series. 1 minus 1 plus 1 minus 1 plus 1 minus 1 forever. And I'm going to call that x. Okay? So just plus 1 minus 1 repeating. Alternating, I mean, not repeating.
This is going to have two values. This could have two values.
Okay, what do you think they are?
Well, if this number ends in a minus 1, it's 0.
Seems like the sum's 0.
if
Wait, do you understand that?
If
the end of this series is a minus 1, it looks like the sum would be 0. Do you understand why that's true?
Well, but the one before it would be plus 1, but wouldn't that be 0?
Well, look at here. If the last term was a minus 1, say I stop it somewhere, and the last term's a minus 1, I can group them like this. I can group the minus 1s with the plus 1s. And what is this one?
That's 0. 0, 0.
So if the last term is a minus 1,
It's
the sum is
plus. It's plus 0.
the sum is 0.
But if the last term is a positive 1.
What happens when the last term is a positive 1? So let me just put a positive 1 here and pretend it ends there.
Well, but then you have all these 0 groups.
Then you have all the 0 groups, and what do you have left?
1, so it's plus 1.
So that's why he was saying it might have two values. If it ends in a 1, plus 1, it looks like the value of the sum is 1. If it ends in a minus 1, it looks like the value of the sum is 0.
But it never ends.
But it never ends. So do you have a guess for what might be a good value to call this sum then? If half the time it's 1 and half the time it's 0?
Well,
maybe a half.
A half, maybe. So let's see. I'm going to do something tricky. I'm going to add this series to itself, but I'm going to shift it over. Like remember how the Fibonacci numbers shifted in those fractions?
yeah.
I'm going to put it here. 1 minus 1 plus 1 minus 1 plus 1 minus 1. That's the same series, right? 1 minus 1 plus 1.
Yeah.
Now what happens when I add them together? 2x equals, well,
Then
1,
1, and then that's 0.
0,
0,
0,
0.
0, 0.
So there's infinitely many zeros and just
So 2x equals,
1.
what does x equal?
X equals a half.
Weird, huh?
Yeah, but this is all integers.
Seems strange, right?
Yeah.
Ah, okay. Told you this was going to be strange. Now you ready for the next series?
Yep.
1 minus 2 plus 3 minus 4 plus 5 minus 6 plus 7 equals some number of x. Okay, alternating positive and negative integers all the way up.
Yep.
Okay. Well, what do you think about this one?
Well, I think on this one, if it ends in a negative number, it's going to be negative. If it ends in a positive number, it's going to be positive.
Ah, very interesting. If it ends in a negative number, how can I group them? You show me, since this was your brother's idea. How can I group them? If it ends in a negative number.
You like this?
Yeah.
So
If it ends in a negative number, I get a bunch of minus 1s.
Yeah.
Is that what you meant?
Yeah.
Good. If it ends in a positive number,
Well, you get a bunch of positives.
get a bunch of positive ones. Okay, so the sum as you go along alternates between negative and positive.
Cool.
Okay, but we still don't know what it is. But I'm going to do my same thing and add it together. Okay, and I'm going to shift 1 minus 2 plus 3 minus 4 plus 5 minus 6 equals x. Same series, right?
Yeah.
Now let's add it together. You get 1 minus 1 plus 1 minus 1 plus 1 minus 1
That's our series from before.
equals 2x. Hey, but this is the series we just talked about. What did that add up to?
That added up to half.
So 2x equals a half. So x equals
A fourth.
a fourth. So this series adds up to a fourth. Does that seem strange?
Yeah.
Yeah.
Why?
Because this is a fraction.
Because this is either a bunch of minus 1s or a bunch of 1s.
Yeah. That's a fraction.
What?
What? It's very strange. Yeah, you ready for the last step?
Yeah. Alright.
All right. 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 equals x, dot, dot, dot. I mean, that's the series we're trying to figure out.
Yep.
Let's look at our other series. 1 minus 2 plus 3 minus 4 plus 5 minus 6 plus 7 minus 8. We know this was
1/4.
1/4. Okay.
Yep.
Now let's subtract. X minus 1/4 equals 0.
0, 0
No, it's 4.
2 minus 2
is 4.
plus 4. Subtracting. 3 minus 3 is
0.
0. 4 minus 4 is
8.
5 minus 5 is
0.
6 minus 6. 6 minus 6 is
12.
oops, plus 12
And then
plus 16. But this is just 4 plus 8 plus 12 plus 16 plus dot dot dot. What can we say about this series?
Well, it's all of the multiples of 4.
Right, it's
Added.
4 times 1 plus 2 plus 3 plus 4 plus dot 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 equals x minus 1/4. Okay, what's this series? 1 plus 2 plus 3 plus 4.
It's
that's x.
That's x, that's what we're trying to solve for, right?
So 4x.
4x equals x minus 1/4.
So 3x is 1/4 minus 1/4. I mean.
3 times x is minus 1/4.
so if you divide by 3, you get minus 1/12.
What?
This doesn't seem right.
This does
But
not
we-
seem
But we
right.
proved it.
Sure seems like we did.
Well,
What do you think? Do you believe this or do you not believe it?
well, we proved it, so it's sort of both.
You believe it and you don't believe it.
Because it just doesn't seem right mathematically, but we proved it.
Yeah.
What do you think? This bothers you, doesn't it? Yeah, what do you think? Does it bother you?
Yeah.
Okay.
Yeah.
It's interesting. Interesting stuff about math.
Yeah.
Sometimes things that
Don't
don't make sense seem to fall out of the arithmetic. I wonder what's going on here. Anyway, this is a good thing to ponder. And it's a good thing to be bothered by because what do you think? If you had to bet all of your Lego guys and you would either get to keep them or lose them, would you bet this is right or wrong?
Right.
You would bet this is right. Okay, what would you bet?
Probably wrong.
Probably wrong.
If I
Okay.
didn't know.
Well, we just proved it.
Well, I don't know. That's why Jordan Ellenberg calls this algebraic intimidation. Because I've put a bunch of numbers on the board and I've done a bunch of arithmetic that all seems right.
But
is there something wrong here that's hiding underneath? It's very hard to know.
Yeah.
Okay? So you guess, if you just had to guess, you'd guess it's right. And
Yeah.
if you just had to guess, you'd guess it was wrong.
Yeah.
Interesting. All right. I'm not going to tell you. Ha ha. All right. Good job this morning, guys.